Well, it's me again. It's been a little while. I have been exceedingly busy. It's been one of those end of last year, but Happy New Year to everybody. And I've got a new toy. Now this is a 600-400 Chinese laser that I picked up a couple of weeks ago. And I think it'd be a good idea if I explain to everybody that these things are not, I repeat, not plug and play. Even if you buy them secondhand, that's probably the worst way to do it. I bought this secondhand. I don't know how much they are new, these bigger ones, but yeah, basically it's a blown up K40. Anyway, what I want to do is explain what I've done to actually make this thing cut thick MDF like this that's coated, and also to cut what's that, 4.55 mil ply with ease, one pass. Both of those are one pass. Now there's several things that I need to go through, and I got to be quite honest with you, I really don't know where to start. First thing, I suppose, if we go around the back, there's the tube, upgraded tube, 60 watt, fires off the end, 3D printed extension box, all good. Original mounts, still fits. The tube, I believe, is a 55 mil tube, and then we'll go through the upgrades in a minute. But if we can just get in here, I want to show you one very important thing, and that is that is a flow meter. That flow meter is critical really to the operation of your tubes. So you've got your water out here, goes down through there, and your water in is up in there. Now what you don't want to see is any water bubbles through here. So there's no air bubbles, sorry, air bubbles, not water bubbles. No air bubbles in your tube. Your tube will last no time at all, and 60 watt tube is going to set you back 300-400 quid. So yeah, that's the first thing. Upgraded tube, 40 watt. It cuts okay, certain stuff, but it certainly wouldn't cut through single pass MDF or single pass 5-6 mil ply. So that's the first thing. Make sure you have water flow meter, you have got a decent water pump. If we look in here, this is just fudged up. That's the pump, I believe, that came with it. Always keep your input pipe here in the water. That stops air getting back into the system, and if you, like I say, if you've got air in that tube, you will decrease the life of your tube significantly. No percentages on this, but trust me, it's a lot. Moving on, so you need your water flow sensor. The laser will not fire if there's no water flowing. Good thing. Bad thing, water flow sensors can kick up, so buy a good one. That one was 23 bucks on Amazon, or 23 quid on Amazon. Well worth spending the money to get a good one. Obviously the next thing is going to be, you're going to want some ventilation. Now I'm going to upgrade this ventilation, but there's only so many upgrades A, I can afford, and B, I've got the patience for. So in here is the standard fan through some tube right out through my back door. I had to make up a panel for that. So that's another thing. Extraction is important because, as you can see, my garage is quite a small garage. It's filled with all kinds of stuff, and what we really need to do is make sure that all those nasty fumes and smoke and God knows whatever else, it won't kill you, it'll certainly make your life difficult when it comes to breathing. Another important thing to do, just bear in mind that nearly everything that I'm showing you was either wrong, it was either incorrectly installed, it was working half its potential. Just the guy who had it before, really nice guy, he was more than helpful when I bought it. He seemed to get good use out of it, but I think he was getting rid of it because he thought it was buggered. Well, actually it's probably all the shall we say, less than engineering minded tinkering that has caused him a lot of problems. Anyway, I'm waffling. Nothing against the guy, really good guy, he did the best he could. Unfortunately, it's not sort of my level of tinkering. It's it's a couple of levels outside of my comfort zone. Another thing to do is earth. You have to earth these things, because there is no telling what kind of BS are in these machines. They are horrifically made. They are made so badly, and then when you get kind of slightly lower level tinker times on it, then it can just get out of hand. I mean, get really out of hand, and dangerous. You've got to remember, these things, they're high voltage. I mean, incredibly high voltage go through these laser tubes, and A, it would make you smart a little bit, and B, you don't really want to burn your house down. Anyway, so the earth there, I've run an earth cable all the way back through to my garage water pipe. Probably one of the better earths that you can get. So that pretty much sums up the back, apart from this little device here. This is a straightforward laser pointer, a through lens. It's called I think it's called a beam merge, or something like that. I forget what it is, but basically the laser dot hits the same mirror as the laser cutting dot, if you like, and they follow each other through. They don't interfere with each other. Beam combiner, that's what it's called. They don't interfere with each other, and it produces a dot of the cutting nose, which I'll show you in a minute. The other thing, of course, is I've pumped in some air assist. I'll show you more of that around the front in a moment, but that pretty much concludes the back. These things are a little bit crap, to be honest, but when needs must, I just wanted to use it. The other thing that's well worth doing as well is I made myself, as you can see, a decent little trolley for this to sit on. Great for storage underneath, keep your water underneath, keep all your bits and pieces underneath, and you can move it around easy. I mean, even if you've got small space, just to be able to move it out of the way sometimes is beneficial. So anyway, that's that bit taken care of. Lots were done there. Now moving into here, I've upgraded all the heads, all the mirror holders, everything all the way through. You can see the little dot there. There you go. That's the laser combiner working with the little dot. These adjustable mirrors, I 3D printed a new bracket. Oh, you ought to see the old one. Hang on. Where's? Just look at this crock. That is Chinesium at its absolute best, is it not? Good God, man. It's horrible. It's absolutely horrible. So anyway, I'll show you the box of bits later. So we've got this, we've got our air assist. I've got it on a curly tube pipe at the moment. It seems to work quite well, so not really that bothered by it. Had to jig around with these a little bit, make sure all of this is nice and rigid. They are very, very sloppily made. These rails are pants. I'll do a video of a future upgrade where I put H-Win rails in, I think. It's just going to be easier. Pretty fortunate, and one thing I did get a bit excited about is that I've got the bed is a motor driven bed. It moves up and down on that switch there, down, up, moves really slowly. It's quite a cool setup. It's chain rather than belt, so proper old school. And there's the motor back there, so you can see all of that. It's quite good. I'll ignore this. There's another crock I'll talk about in a minute. So yeah, so long and the short is that you fire a laser pulse. Shouldn't really do this, but it's set very low, and boom, cut. Turn the air assist on, and close it again. As you can see, all works a treat. So I put a little crappy light there. It doesn't really do much. What I need really is lights up in under here. But to be fair, you don't really need much in the way of light. It's sort of pointless. A, you shouldn't be looking at it. B, you only need to line up where you're going to start and where you're going to finish. You can see I've done a whole bunch of test cuts. Some failed, some not. But this is all about another aspect which I'll come on to in a minute. So at the moment we are, what, 4 days into adding all these components, 3D printing the components, making sure everything's tight, making sure everything fits on in here, and adjusting a few odds and sods, getting the beam combiner working properly. Just so much effort just to get it to a level that actually makes it function to its potential. Because 60 watts, to be fair, CO2 laser, 60 watts is a decent amount of power. You're unlikely to need anything more than that, really, unless you want to get into proper metal marking. Then you're up around 150, 200 watt laser tubes, and they're going to stick out, well, probably out my garage door, because they are long. They're 2 meters. They are seriously long tubes. And the benefit of that is that you may be able to mark metal, you may be able to cut metal if you put oxygen through your, you know, kind of through the nozzle, kind of through the air assist. I haven't really worked out how you do it yet, and I've got to be quite frank with you, I'm not really that bothered. If I want to cut something, as you guys know that follow me and subscribe to my channel, thank you very much. I've got a pretty accurate plasma cutter in the workshop, and I'll just use that. Anywho, so that's basically so far here, and like I say, we're 2 to 3 days in, just getting this far to the point where I got it working. This has got to go. This is the ribbon cable that does all the stops. You'll see that there's some optical stops there. They're a bit pants. It's just so cheap. I mean, what do you expect when, you know, with what you pay for? But it is just so ridiculously cheap. And cheapskate engineering, not really that impressed with it, but it does work quite well, I suppose. It does what it does. As anybody will tell you, K40s are not built to the highest quality, and they sure as hell need a lot of tinkering to get them to work at all, really. The mirror lining up was an absolute ball ache. I went through loads of tutorials on YouTube and everything else, and it just, I wouldn't say it baffled me, it made sense. It's just, my God, those guys make it look easy, and it really isn't that easy. Trying to get the parallel laser coming out here, ignore the mirror, you've got to get that laser line firing out through here, dead parallel to your bed. Now the thing is, you've got tiny bits of adjustment on these bolts. These are slotted holes, and you can move the entire bed to try to make that fit. Don't do it. It's really hard work. If you can get it set up, spend a lot of time setting it up first time, and then just do not touch anything. I mean, I had this bed in and out. The worst mistake I made, because I lined up the mirrors, got it all cutting, decided, oh, I know what, let's put a new belt on. New belt. So I had to take it all out again. When I took it all out again, put it back in, of course, because these are slotted holes, and the mirrors didn't line up again. Then I had to realign all of that. So yeah, the mirror alignment, no matter how easy they say it is on YouTube videos, theoretically it's easy. In practice, it's a royal pain in the ass. So if you get it near enough, you should then only need to adjust, you know, the mirror angle rather than the actual beam itself. If the beam is coming out on the piss, you will never get these mirrors to line it up from this end to that end to this corner to this corner. You just won't. So you have to make sure that that laser beam itself fires directly parallel. It can be up, it can be down, not a major issue, but it has to be directly parallel to your to your running gear, to your axis. I think I've waffled on enough about that now, but I cannot tell you the importance of getting that part right first. Get that right first, and believe you me, the rest is just a breeze. It's a walk in the park. So anyway, that's that lot done. Moving on to the panel. This is very much a work in progress, the panel. I would say, next to making sure water is flowing through the tube, the next important piece of equipment is going to be this, a milliamp meter, and your pot to control it. The original K40 board thing, this, with the associated bullshit electronics, this gives a representation of, oh, it's 10%, and then there's 1%, and there's 0.1%. it's shit. It's not even close. If you run a multimeter on it, you set it at 50%. In theory, at the power supply, which I'll show you in a minute, that should read 2.5 volts. You got 0 to 5 volts, 0 being 0%, 5 volts being 100%, therefore 2.5 volts should be 50%. Nope, not even close. That reads 30% on here, 32% I think I measured it at. Well, you're going to destroy your tube in no time at all if you say run it at 80%, because what you're actually doing is running it at 100%. No CO2 laser tube loves being run flat out, that I can assure you. Your 1,000, maybe 1,500 hours of working time will decrease dramatically. So first thing, bin this. In the bin, okay, and replace it with manual stuff. And what I mean by that is you have your pot here. I've done it see-through just actually so I could show you. So you got your manual pot here. So you've got your ground, your center tap, which is going to be your output, and you've got your 5 volts there. So this being a 10k pot, I wouldn't use anything other than a 10k pot, to be fair. You will find that there are really good pots that you can use. Let me just see if I can find it. This is the one I wanted to use, but it didn't turn up in time. I got impatient and I stuck in that, but that is a 10k, and it's got, I don't know whether you can see actually, but it's got very nice, will it focus? Yeah. It's got nice fine grain dials on there. It's just quite cool. I will fit it, but just not now. I haven't got the will. And this is more than ample to do what I want to do. And like I say, with a 60 watt tube, you don't want to be firing more than 15 to 20 milliamps. I've got a 50 amp meter because I might just monster this one. I might just stick in a 150 watt laser tube if I can garner the money and the will to do it. Which, I mean, it would probably stick out, yeah, here somewhere. But that's why I got a 50 milliamp meter. Normally a 20 milliamp meter or 30 milliamp meter for a 40 watt, a K40, 40 watt or 60 watt will be sufficient. On off switch, that turns on and off everything. Oh, funny, it's flickering on the camera, but it's not flickering in real life. And then that's my air assist. Green and red buttons, there is a really good reason for that. The terminals on this one half, because this is the original on-off switch that came with it. The dude had soldered on some wires instead of using spade connectors, and he'd wrecked one half of the switch. So that switch now only operates the air assist pump. This one is a 4-pole, so that it can, is it 4-pole, 2-pole, I don't remember, so that it can switch the negative and the live. So that's quite important. Extractor fan button, I don't know why you'd turn it off, but hey, it's there. So I do use it occasionally if I want quiet. So there, it's a little bit quieter. The only noise now is the water pump running, which I do tend to keep running all the time anyway. These two buttons here do nothing yet. They will be for other stuff once I start adding to it. For instance, it could be that the white may well be the cabinet lights when I put more lights in here, and the blue button itself might be for something else. I'm considering turning the beam combiner red dot on and off. I don't know why. It's sometimes some things are just nice to turn on and turn off. So, for instance, if I want to change out the laser, the red beam, I don't really want to turn. Might not want to turn the whole machine off, and might want to just keep that pump running, the water pump running. So in that way I could change it out. Which is what this one here is for. This hole here is actually for the water pump, which is, I'm going to put that on a switch. The only real good reason for having that as an on and off, again, is to test everything individually and make sure it's all working. So I'm going to fire up the whole machine. I'm going to go through the homing process, blah 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 blah. So I should be able to just, I like isolating out each individual mechanical component or electronic component if I can. It's slightly barmy. Most people call me nuts for it, but I just kind of like it that way. So moving from that panel, now I've explained that bad boy, all of this in here needed rewiring. It wasn't that it was super bad, it wasn't that it was super good. There's a whole bunch of things on there that were just so wrong. For instance, this power supply wasn't earthed, so I had to put an earth cable in. I mean, just imagine that for a minute. That is 240 volts, okay, dumping out 24 and 5 volts, and it wasn't earthed. Why, oh why would you do that? I don't understand. Anyway, they did, and I've changed it, so now it's earthed. That's my air assist pump. The reason all this foamy stuff's here is to stop it rattling like a bitch. It makes one hell of a noise if it's not on some kind of foam stuff. So I wanted it in there out the way anyway, because otherwise you've just got loads of bits plugged in everywhere, and I've just integrated that into my 240 setup here. I've also got a 5 volt multiple area. I forget what these are called, but it's like a little bus bar, and there I've got my common bus bar. I didn't want to move too much around, to be fair, because it didn't really make sense. In there, that is the M2 board. I think it's called an M2 board. It's the most basic Chinesian board you can lay your hands on, and it will be changed out, but not for a little while. I'm finding that at the moment it's working for me fine. These are dodgy as all hell. They are just hideous, so that's my next task, is to put some decent connectors on there. I think I'll just put new ones of these on, cut these out maybe, and just make it work, because in there is a mess. It's horrible. Just an absolute mess. Just so as you know, this line here, this blue one and this black one, this comes out of the power supply, or if you like, it goes in, but the black wire comes out of the power supply. It goes up to the milliamp meter. You can just see the two cables down there and there, and you just intersect that end of the laser tube, which I think is the negative, and then there's the HT lead for the high tension lead for the high voltage that comes from the flyback transformer that's in there, which produces the super high voltage. These power supplies are quite cool. They've actually got a little LCD on there, or an OLED or something like that. I don't know what it is. Either way, it tells you that your water protection's on, and it tells you the laser signal's off, and it gives a milliamp reading. So that's quite good. Explaining these is for another day, but suffice it to say that the H is activate the laser on a high pulse, which is 5 volts high. Activate the laser on the L is activate the laser on a low pulse. So it's active low, so the laser fires if you put in a 0 voltage there. The P is for the water pump, and limit switches and things like that. Basically it's a 5 volt circuit that if it, I think if it goes to 0, it goes to 5 volts, I can't remember which way around it is, then the laser will not fire, and that's what my water flow meter is hooked up to. Then you've got, I believe you've got your ground, then you've got your in. Now your in is what dictates the, and 5 volts at the bottom. The in is what dictates the ampage that you're firing out to the laser. So on your partly potentiometer, that middle wire there goes to the in. So that is anywhere between 0 and plus 5 volts, which is 0 milliamps up to probably about 25 milliamps is what the laser tube would take, but you should never ever go up that high. So this thing never runs flat out. I had half a mind to put another resistor in there to make sure actually that it didn't, like, just to make sure I couldn't go above kind of 4 volts on this out. Then that would mean that I could never be able to fire the tube at 100%. Just me protecting myself really, as well as protecting the tube. So yeah, that goes in to the in, and then at the bottom there you've got 5 volts. I don't know why my camera's not focusing, but there you go, that's Samsung for you. Yeah, so other than that, that's all the gumph up and under there. Nothing really to write home about, but there's still a lot of rewiring to do down here. That is an absolute mess. Like, all in here has been tidied up. Like I say, the M2 board, or whatever it is, I've got a spare one of those, so I'm not in any hurry to change that out. So this is the machine sort of as it sort of is. It works well. I mean, now everything's been tightened and now everything is you know, kind of on the money. Top tip though, don't ever put your fingers anywhere in between that mirror, or that mirror and that mirror. I did it once by accident, so yeah, you know, don't touch. What's the first thing you do? Touch it. So yeah, be very, very careful. That laser shit, that burns. That is a serious ouch beam that you can't see. Always use eye protection. I've always got eye protection here. And before anybody gives me a good old flame, I know it's the wrong colour, but the right colour ones are on order. They should be orange red in colour, almost like that Sainsbury's bag. And the same as that perspex there, that should really be the kind of the orange red colour, same as this sort of tube, because the wavelength of this laser, I believe, is in the orange spectrum. Don't know for sure, but I do know that the orange red does definitely filters it out. I haven't read up much about lasers and the wavelengths and all that kind of business, because quite frank with you, I'm not interested. What I do know is that you do need proper eye protection, and you do need proper glass protection. This is all cracked and split anyway, so it needs replacing, and I will replace it with the right filter to make sure I don't get blasted. The other thing as well that I'm going to do is definitely put a limit switch on here. Typical Chinese, there is just no safety involved in this thing at all. So what we need to do is get a limit switch on there, so that when the cover's down, it does the same as the water switch. It wires into the same circuit. It's just chaining them serially. So if that one there breaks, which is the water switch, laser won't fire. If the water switch is fine, but the lid's up and the micro switch is open, then the laser won't fire. So the water switch has to be closed and the lid has to be closed before the laser will fire. Follow? So I mean, that's just a little bit more safety there. It's quite imperative, because you can blind yourself with this laser, and it's not really on my list of things to do, to be quite honest. I quite like seeing things, which I'm sure everybody else does. Anyway, I digress. Okay, so to run this thing, Lightburn. Now, I know a lot of people are going to squeal at me and say, you can't run Lightburn on an M2 board, blah blah blah. Nope, you're right, you can't. Not directly. You can indirectly, because if you use Meerkat and you have it in reader mode, because I don't really know why this isn't focusing, it's pissing me off. If you have it in reader mode, then that's the last you'd ever need to see it. Then you can fire up Lightburn. Lightburn recognises the device as a reader device here. Yep, you can list your devices, and there it is. You just add a reader device, and job's good. That's all you have to do. You point it at its own local IP address, which is 127.0.0.1 localhost, and it kind of uses a network communication protocol, TCP over IP, to communicate with Meerkat there, which then communicates with the M2 board. Sounds complicated. It really isn't complicated. There's a wealth of YouTube videos out there to show you how to do it. I did this in about 30 seconds. Okay, and if I can do it, anybody can do it, believe you me. There's a whole load of stuff I could drag on about Lightburn, but to be quite honest, again, there's a load of videos out there. It is very, very basic. That is what a 100mm square, which I'm going to cut on this ply now, just to show you it all working and to show you the milliamp readout and all that kind of business. So yeah, that's pretty much it. That's the update on the machine. There's so much more I could talk about. The machine was in such a poor state. I can't tell you. I mean, this is my this is the box of bits. That thing was shit, of course. I bought some laser pointers for the in-beam. The state of these mirror holders made me angry, purely because it just looks crap. And not that I'm massive into the looks of things, but that really just looked as though it would never do the job. And this thing, although, you know, I'm sure the lens is okay, I haven't even taken it apart, you know, because I just thought, God, that looks awful. And I don't really want to, bit snobby, I just didn't want to fucking well use it. It's awful. It had all kinds of weird stuff bolted to it. To be fair, the mirrors are alright. The mirrors are pretty good. They're just dirty. So I'll try to look after those a bit. Might put them actually in the mirror case, that'd help, wouldn't it? That's the lens case. Like I said, it's that piece of crap. So yeah, there was a lot of really awful things on this. It was quite dirty. One thing I didn't mention, actually, it actually got a rotary control. So you plug your rotary stepper motor in there, and you just switch it from linear to rotary. And in Lightburn you can use rotary, and in Meerkat you can use rotary. And down there I have the rotary table thingy-me-jig. Again, I haven't actually looked at it to see how it works, because I've only got so many hours in my day and only so much of my life I want to tinker with. But suffice to say, it will do it. I haven't tried it. I will try it, because I'm quite like the idea of etching glass. Whether or not I would turn this into a business or a plaything, I really don't know. I think I'm getting on a bit now. I'm getting a bit long in this tooth, and I would just like to be able to just knock a few bits and pieces out. I did a few, as an example, I did a few coasters for my wife. She's an opera singer, so there's a musical note on there. I did some musical notation. I did some stuff for father-in-law for Christmas. I did some stuff for my mother for Christmas, all on this machine. Pretty much before I upgraded it, which is how I knew it was a bit pants. So yeah, I mean, it's a lot of fun, and to be fair, compared to metalwork, it's not really a lot of hard work. The hardest work is keeping the damn thing going, to be honest. There is it does etch cardboard, so there we go, look. So that does that quite well. It cuts quite thick stuff. It will not etch metal, it will not cut metal, it won't do anything with metal. It'll just sit there firing laser at it, and because it's the wrong wavelength and the wrong gas assist and all that kind of business, you ain't ever going to laser cut metal with a 60 watt CO2 laser. 60 watt fiber laser, maybe something completely different, but that's a completely different tool altogether, with many different nuances in itself. So there we go. So what I'm going to do is that I'm just going to reach for these a minute, and I mean, they might help a bit, but who knows. And then to fire this, just so that you can see it cut and see what it gets up to. So what we do here, we press on the start button, and then we look at this, turn the air assist on. There's a difference between no air assist look and air assist. So let's work a little look. You can see the milliamps around about 10 milliamps, which is about right for cutting this. You can see the smoke lit, and that's with that crappy fan going. So you can imagine that it can be quite a bit, well, it can get pretty smoky around here, even with that fan on. So you need decent extraction for sure. Alright, so there we go, it's cutting away. Mind your eyes. And you can see it's quite a nice line. It's not that it's a bad look or anything. Not that it's a bad thing at all. And there we go. And that hasn't quite cut through. That comes to my next thing, which is a focus gauge. Now this is why I wanted to show you. A focus gauge, that is far, far too high. It should be on, you see that? I've got it on the middle one. Yeah, and we have got far too much height there. So we bring the table up until it suits the height. Up a bit more until it's nearly there. A little bit more. If I had more hands, I'd be, and there we go. So what we can do now is that we can fire this off again, and we'll do what's called a second cut on it. So once we get the second cut going, it will cut a little bit faster than this all the way through 4.5 ply. But it is worth just showing you that sometimes you've got to do, especially with screw up like I just did, because that's how organised I was. Sometimes it takes 2 cuts. Sometimes you'll see stuff like that going on. That can be the glue in the ply. It can be all kinds of different issues. It'll fizz and fart. This is just cheap ply that I just got. Well, off a scrapyard or out of a skip. So there we go. That's cut, and it still hasn't cut all the way through, not quite. So let me explain. Let's pull that out of there. Oh, it has actually. It has cut all the way through. Let's put this here. You can just see a few bits that it hasn't cut. Quite often that is glue with this sort of ply. So hang on. There we go. Oh. So can you see how that hasn't cut? It's probably the glue or something like that. It's just, you can actually see there's some kind of line that runs through there, like from one side to the other. I don't know whether you can see that. It's just like a faint line. So that's going to be something that the laser objected to, which is why you need pretty good quality ply. These are sort of some of the problems with laser cutting anything. What I am going to do is I'm going to see if I can do it again over the same sort of area. The other thing as well is, because the ply is bent, sometimes you can just weight it down. Yeah, so got a big bit of aluminium, weight it down on it, make sure it doesn't foul anything. Check the height again, which is a bit low now. So just gauge the height again. Yeah, that's going to be near enough, I'd have thought. So now we can, oops, I'm just going to give it just a little bit more power, not a lot. There's a test switch there, test button. Yep, I'm about 12 milliamps. So let's give it another go. Click start and see what it does. So now we've got, we're bang on focus. We've given it a little bit more power. There doesn't appear to be any more of those weird blue lines, but you will see it because the laser itself will pick up. Could be coming up to this piece here. Nope, no objection there. So before you start tearing your hair out, if you get yourself one of these, oh, there's a little bit. Before you start tearing your hair out, if you get one of these, just bear in mind that the quality of your material matters as much as really the quality of the laser light itself. So here we go, it's coming out of this now. I'm expecting this to sort of drop out because it looks as though it cut beautifully. Not quite, but not bad. Okay, let's remove this. Stick that in there. Let's pull this out and have a look. And I wouldn't mind betting, yep. So in exactly the same place that the laser didn't cut through there, it hasn't cut through there, or there, or there, or there. Now, if you have a look at these other cuts that I've done, the same applies here. Can you see how that line follows through? Now when I first did this, I thought, oh, it's got to be, and actually, if we pull this out, if we can get it out, oh, here we go. Right, now you can definitely see that the line goes through there, through there, through there, 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 and there. And the same there, there, and just about there. So you can see that the quality of the material makes all the difference as well. So it's not just quality of the laser light, it can be the quality of the material. Now there's a good chance that you could do this in many passes as you like, and you still will not cut through that, because whatever that is, it doesn't like it. However, let's just have a look. Like I said, I don't know why it's not focusing, but that's a clean cut. It's just a clean cut. It's just those funny little knobs there. So, just goes to show that, as I've already said, material. It's the same in the steel business. If you've got crap steel, you're going to have a crap job. Let's take off these a minute. There we go. Oh, now I can see what I'm doing. So, that pretty much brings us to a conclusion, really, of this. In fact, I'm going to chuck this away. That's just pants. There you go. In the scrap list. Oh, the other thing, by the way, is not plexiglass, but acrylic. Oh, I love cutting acrylic. It's what these things were built for. You can see a couple of screw ups there and a few other odds and sods that I've messed around with, but acrylic is a hot thing to cut. I mean, it is just such a nice stuff to cut. Engraving on super hard surfaces is cool as well. Being able to cut 10mm MDF one pass is cool. There is some other stuff as well. Let's have a little look. Let's move that out the way. This is 8mm ply. You can see I had a couple of issues, but once I've dialed it in, one cut right through, no problem. So that's 8mm ply, and that was quite good. There's these, I've got an unlimited amount of these kind of plasticky cheap boards, and I have to say it cuts really well. The stench is not very nice. You can see that I was having troubles here, and then it rectified itself. That was the air assist line was twisted, and you can see that it's come out perfectly clean once I've rectified the old air assist. So that's that. Now, to stop from boring you anymore, I'm going to close out now. Thank you very much for bearing with me. We've had some real busy times, and it's been a challenge. But I just thought I'd show you this machine and show you the difficulties in it being a Chinese laser, or the K40 series, or what they call a K40. Actually, it's a monkeyer to a degree, because it just relates to so many different Chinese lasers. I just thought it was worth explaining that although they're a great little tool to have, or a little toy to have, the work involved in these, as opposed to some of the posher lasers, might not be suitable for some people. Buying them secondhand is really a bit dumb. I think if I was to buy them again, I would just save for a few more months and buy new. The fact that it took so much effort to bring this to a standard that made it function relatively well is sort of not really worth it. I'll be quite honest, I'd rather buy a K40, upgrade the tube myself, upgrade the power supply myself, upgrade the control board myself, put in all the air assists that I need, put in some decent mirrors, decent lenses. I mean, if you think about it, the amount of money that you'd spend upgrading with panel meters, pots, switches, like I say, power supplies, control boards, mirrors, mirror mounts, beam combiners, laser tubes, all the wiring that comes associated with it, Maybe upgrade the stepper motors, slightly powerful, more powerful stepper motors. Maybe put on better running gear, so that this is 3D printing style sort of wheels. No offense, my 3D printer sat right there. Creality 6 SE, fantastic machine, but I'm not sure it's worth going through the agony of upgrading all of these, especially if you're not that way inclined. It's just a lot of work, and then trying to get one to work with its original bits and pieces is nigh on impossible, to get it to work to its proper potential. So anyway, if you do like the video, then do subscribe. I know it's somewhat off topic compared to what I have been doing in the past, but I just want to get some content up there so that you guys can see exactly what goes on in my life that is a little bit barking, and I will have a go at anything, which is why these videos are somewhat varied. So anyway, as I've already said, Happy New Year to everybody. Hope you had a great Christmas. Stay safe, and like I say, please subscribe. If you like the video, give us a little thumbs up. If you don't, you can hit the dislike button now. They've done away with the thumbs down now. I guess they got to be politically correct. You don't want to go upsetting any of these fairies, do you? That would be really bloody unfortunate. They might end up crying to YouTube or whoever. So yeah, all the best. Thank you very much, and I will see you soon. Cheers.